Right, I think we can get it started. Hi everyone, and welcome to today's meetup. We will have Felix talk to us about how to use Kibana effectively to detect possible frauds in our data. My name is Dalia. I'm from the community team of Elastic. We always look for speakers for our meetup. So if you have an awesome use case or anything interesting that you think it's worth presenting, you can always reach out to us. You can send us an email to meetups@elastic.co if you want to present something. Anyway, so I will give the floor now to Felix.
Yeah, hello and welcome to today's meetup. So we will talk about, that already said, about how to use Kibana effectively. So the target group is mainly for users that already know how to use Elastic, how to use Kibana, and also know, of course, also the whole Elastic stack. So I will not go into the basics. I will already dive deep into how to use Kibana. So feel free to ask questions if you have, if you think that you missed something. We also record the session, so you can always, well, listen to the recording and see the things again if you missed something. Well, I have my son in the background at the moment because it's late today. I hope this is not too much disturbing. Yeah, so let's start with a little introduction. One second. Okay, so let's start with a little introduction into the topic. So what we will cover today is how to use Kibana for fraud detection. So fraud detection is a special case where we try to detect possible fraudsters in big data, also on every kind of data, but especially in data which can include fraudsters. We will also see how to visualize data professionally and how to create drill downs, different drill downs into the data in Kibana, which is really helpful to dive from a high level overview into the real raw details of your data. Yeah, and of course we will also have a look into different machine learning techniques and into different visualization techniques in Kibana. So we will use many different machine learning jobs and also graph visualizations in Kibana. So a lot of different things we will cover today, and from a Kibana perspective, but also from the use case perspective, which is the fraud detection. And if you have a look into fraud detection and why we should use this, so fraud detection is a thing that is important to observe. One second. Sorry for that. So, so fraud detection is something which we need to do externally, or which many companies needs to do externally, because the internal control systems usually have not the focus on doing fraud detection. So they are really good in doing their internal control stuff, but they are not that good in detecting frauds in the data. So to detect whether there is a special pattern happening, whether there is a special thing happening which could be a possible fraud. And that's why we need to collect those data in a separate system and check whether there is something happening which could be interpreted as a fraud. And of course, to detect fraudsters can be crucial for the business success. Imagine you have a system, let's say a gaming system, and you have a lot of fraudsters in your system that are doing their stuff, and other users get distracted by your platform. So just because of this, so it's really important for many use cases to detect fraudsters. It's also important, for example, to detect people who try to make fraudable stuff in taxes, for example. So if you are working for the government, you may want to detect those. The only thing you need to do these things with Elastic is to have the right data in place. The right data can help you to do all the observations and to detect all the different indicators to finally also find who is a fraudster and who is not a fraudster. The problem is it is quite hard to detect those people. So there is the one problem is you probably need, or you usually need, a pretty big amount of data to detect fraudsters, because you cannot have a look into one single window of your data. You need to have everything in place to really look at all the different angles, to have an overview, a high-level overview about what can happening into your system. And of course, the other way, or the fraudsters also try to hide themselves. So they create multiple different accounts. They have a lot of different techniques to hide themselves because they don't want to get detected. And we, as fraud detection people or people who are working with the data, want to detect them to protect our business. And this is just, that makes it pretty hard to detect those things. And if we have a look into what makes it so hard, we can ask ourselves, how would we identify a pattern like this? So we have different accounts in our web application that in our bank, for example, and there is money transfer going on, and we would like to detect a pattern like this, where person A is transferring money to person B and up to person C and to person D and back to person 1, and just to let's say hide their direct connections. So this could be a problem or a fraudable behavior, but it's pretty hard to detect if you just look at aggregations or things like this. So we need something that is able to detect those things. And on the other hand, only to detect that something like this is happening does not mean that that this is already a fraudster, or that the fraudster is doing those things. It could be also pretty normal, normal cash flow, for example. But we need to detect those risk indicators, combining different risk indicators and checking at the end, okay, if there is a person who has multiple risk indicators attached, then if this is the case, we can be really sure that we have found the fraudster, and so that we can go the next step and exclude him from the system or something like this. So let's have a look into the data, into one kind of data we will analyzing today. So in this case, we will check for bank transaction data. So we have transactions that are made by different devices from different locations. We have included data from nearly 1,000 different customers making 5,000 transactions. So a lot of data. This is sample data, of course, or mock data, which I mocked with a specific tool to get test data. This is just to give you the first insight into how to use those systems. And in the second part of the presentation, we will dive into real data, into real Airbnb data, and we will see how to detect things like this. So we have in this case, different hosts that have multiple listings, and these listings are sharing identical photos. So we will also talk about how to detect those things in real Airbnb data. Maybe some of you have seen my LinkedIn article about this talk, and I also have shown some examples of how to do this. Okay. Yeah, so let's start with this. And by the way, this presentation is 100% a demo presentation. So I'm already in Kibana. The full presentation was made in Kibana, and also all the things I will do from now is live demo. As usual, live demos have a little risk that things can fail. I hope that everything works fine, and that you understood the different tricks and techniques to get data together, and finally also that you get something really valuable for you for your daily business using Elastic, and that you can use those information for your daily business. Okay, so let's start. Again, if you have questions, please put it into the chat, and I will answer this at the end of the session. Yeah, so I talked about the bank transaction data. So let's have a look into this data first. So we will have a look into a specific dashboard here to check which accounts we have. So just to get a little overview about what is happening. So we have different things here. We can put everything on a timeline, so nothing special. I think if you already worked with Elastic, you know all the things. But what we really want to do is to transform or to detect accounts or bank accounts that behave anomaly in comparison to all the others. And the first thing we need to do to get those things, we need to transfer transaction events into an entity-based index. And this we do this by using transforms. So transforms is a part of the stack management here on the left hand side navigation bar. By the way, this is version 7.8. So so if you're not on 7.8, your navigation looks a little different. But it's still in stack management. Transforms are available for a long time already, and transforms are already available for a long time, and you can find this in stack management here on the left-hand side. If you look into transform, a transform is pretty easy to create. So the only thing you need to do is to decide for a data source. So in this case, we can, for example, use a data source with multiple different indices in the backend and in the background. So this is our index patterns, right? And usually we write index pattern like this, but you can also combine different types of indices and by separating it with a comma, and then you have the data out of the access indices, the customer and the transaction indices, which is pretty helpful to get an overall view of one entity. Because what Elastic is working the best way if you have a flat index. So every data that is relevant for your analysis should be in one single document. But usually, if you look at data from structured data sources like SQL, you have relationships between different tables, and there are primary keys shared to each other. And these primary keys we need to put together to make a flat index. We can do this also via in the ingest time frame, but we can also do this after ingest, and then we use transforms. So transforms are pretty easy. So we have now here all the so in the first part we do the configuration, and the first thing we have to do, we have to decide how to group the data. So we can group, for example, by customer ID, and then we have one group created per customer ID, and then we can add different metrics to this customer ID. So for example, we can check for the average and for the max amount of data or the max amount of money that has been transferred. We can check how many different devices he has used and all the different things. We can also use scripted aggregations to get more sophisticated, let's say, features or parameters to our entity-based index. But this this transform aggregation already help a lot to get good insights into the data. So I will not do this fully here. I will copy one of the existing jobs. So this was the wrong one. This one. I will copy this one, and what I made here is I aggregated or grouped by the account ID and created a couple of aggregations. So for example, when the account was created, how many devices he has used, from how many different geo areas he has accessed the platform, how many IPs he has used, and things like this. And at the end, I got to an index for every account ID. I got many different information about how this specific account ID is behaving in my system. The next step is then to decide where to store the information, which index, and whether I want to use this in a continuous mode or not. Continuous mode is really helpful if you would like to have this index always up to date and not only to do a one-time shot. So if you want to do a one-time shot, then you leave it like this. And if you want to get updated over the time, then you do see continuous mode here. And then the next step is just the creation. And then it will re-index everything in a new index, and then you have an entity-based index. And the entity-based index is really the base for doing outlier detection and other high sophisticated stuff in the machine learning mode. So so imagine we now have created this transform here, and we have a resulted index. And now we use this resulted index in our machine learning parts. So I'm now back in Kibana in machine learning mode, and in the machine learning mode, I now use the data frame analytics stuff. So data frame analytics helps us to detect accounts that are suspicious in their features. A feature is one of the columns we have created. So one of the aggregations we have created is now called a feature of one specific entity. And if we would like to find accounts that are suspicious or that are outliers in one of these or multiple of these different features, then we use the data frame analytics job. And I know that it sounds a little hard to do those things, but I want to show you how easy it is. So you see I already created a couple of this, but I want to create a new analytics job just to show you how quick and easy it is to create a new job. So we click on create new job, we choose a job type. We have 3 different job types here. So the outlier detection is using the results of the transform and to do this outlier detection in the features that I described a second ago. A regression job and a classification job are using pre-trained machine learning models to detect, for example, a specific statistically, let's say, interpretations of the data. And for example, classification, let's say we have 20 different features or 20 different sensors that result into a working or non-working state. And you can use the classification machine learning job to detect those things based on the features, so that the class working or non-working can be detected based on the incoming data. The full workflow can be done with Elastic, so we can train the model, we can test the model, and we can also execute the model against the incoming data. But we will now check for outliers, so we will use the outlier detection job. We will give it a job ID. So let's call it meetup talk, and then we choose the source index. So we can use everything as a source index, but for this outlier detection job, it would be really helpful if the source index is an entity-based index. And again, the easiest way to get an entity-based index is to use the transform stuff. So we will click on accounts with metrics, choose destination index. So we will again call it meetup. We can exclude fields. So we can exclude specific fields. So it's, for example, the sum of the points is not relevant for my model. I will create an index pattern for the result to get access to the result finally. And now I create the job. And that's all. So the job is created, I can start it. And now my meetup talk job is working. So I can see that it is re-indexing now, that we're in phase 1 of 4. And it should not take very long time to detect those outliers here. In the meanwhile, I will show you, or let's check how long it takes. Are we already done? So so this is everything we need to do, and now we click on view, and it should show us the results here. So we see that we have an outlier score. This was created by the machine learning job, and my data has included some let's say hackers that do something special. And the main thing here is I wanted to detect those special accounts. And you see my main hacker account here is also the most suspicious one. So he has a really high outlier score. And I also have my personal bank account here, so to say, and I have a couple of different other hackers that are behaving special. And I can now really detect those things based on the data frame analytics. It does not mean that they are really that they are doing fraudable stuff, but this is one of the indicators that we could use to detect or to check that this specific account might be problematic. So and this is a really good one because it analyzes many different features at the same time, and it also compares the stuff against all the others. So it's really easy to detect whether something is problematic or not. So a good thing to detect users that behave special in comparison to the rest. Yeah, so the next thing I would like to show you in the terms of bank accounts is to detect those circle patterns I have shown at the beginning. So and now we go back into the graph mode. So we have I have different graphs already created. I will create one that is using the transactions per customer. So I will click on this. So it's a pretty easy graph. So the only thing I've made is I switched the settings to have a certainty of 1, which means that every document that is there should be already result into a connection, and I disabled the significant links because they are able to they have the probability to not show the things we would like to see. So I turned this off. So these are the only two things I've made. And then I said, okay, I would like to see the connection of a customer and an IBAN. So an account or and an IBAN is included into the customer. So every customer has its personal IBAN, and every transaction is including a customer ID, which is the sender of the money and the IBAN of the receiver. So really simple data and also really simple graph. And what we now want to do is we would like to check whether we could find, let's say, suspicious patterns. And we do this by just searching for everything. So we do not search for something special. Of course, we could also search for something special, but we would like to search for everything. This took some seconds now because, again, it's quite some data, and it is my demo environment, which is pretty small. But what happens now is that the graph shows us what is happening with IBANs and users. So we see, for example, this user is somehow related to this IBAN and to this IBAN. We see that this user is related to this one, so it's probably his own one. So we can instantly see some normal patterns here. So if we zoom out, we see that there are many of these normal patterns in our data, but we also see that there is something special happening here, or something that is not in the normal patterns. And if you look at this, we see that there are connections here between the different accounts, and that they have a circular transaction row, so to say. So customer 2 has a connection to this IBAN, to this, and to this. And there is a lot of transaction going on from 2 to this IBAN, which belongs to the account number 3. He is transferring money to this IBAN, which belongs to account number 1, and account number 1 again is transferring money to this IBAN. And this is a circle which is quite hard to detect, again, with simple aggregations, but it's really easy to see if you have a visual way like we have it here in this example. The next thing we can do, so now we know a bit about our, so we have seen the pattern, and now we would like to learn more about our users, so we can enable, or we can, let's click on the different users and select it. And then if we would like, we can also dive deeper into the data and use drill downs. So in this case, I can only show the raw documents, but I will show you in the Airbnb example in a second how it looks like to jump over to another dashboard. But this is just to show you how easy it is to detect those specific or those suspicious patterns. Okay, so let me have a look. Yeah, so this is what I wanted to show in terms of bank transactions. So again, this is real mock data and it's easy stuff. The next step is a bit more complicated. Now we would like to I would like to look into real data, and this data comes again from Airbnb. So let's have a look into this Airbnb data. We see this Airbnb data here is from Berlin, and the first thing I would like to show you, so if maybe there are some people here listening to me that have no data like this in Kibana, or maybe you're using Excel lists or something like this to do those detections at the moment. And the first thing I would like to show you is how I get the data into Elastic for this Airbnb stuff. So what we have in the machine learning area is the so-called data visualizer. Yeah, to reopen it. 1 second. So we have the data visualizer in the ML part of Kibana. And this data visualizer is really awesome. It can be used to upload data of a file that contains data of any form. And then it auto detects the structure of the file, so whether it is CSV or a JSON file, or whether it is a simple log file without any, so which is in a common format, but and using a timestamp, but which is not already known to Elastic, and then it can tell you how to get the data in. And I use this to load the Airbnb data. So for example, so the Airbnb data that you can download exists of listings, of reviews, and of calendars. So the listings are the let's say the houses itself. The reviews are the reviews of the people who has slept in one of the listings, and the calendar is whether the listing is free or not in the future. And what we can do is we can easily use those CSVs and check for a specific and load the data into Elastic. So I'll do this now. So it takes only a couple of seconds, and now the 80 megabyte file has been loaded and the structure was detected. So I can see, okay, I have maybe let's have a look into the file first, because it's really hard to detect those things that we see here just by looking at the file. 1 second. So this is how the file looks in a normal editor. So you see the names here of the different columns, and you also see what's in there, but it's really hard to get insights into what is in this file and what the hell am I looking on. And now we have uploaded the file, and we see in Kibana, okay, we have ID, many different IDs, so 999 distinct values in the first 1,000 lines. So there is seems that every line has a distinct ID. We see the names, the host IDs, host names, and also what we have here. So we have a latitude and longitude, so we can put the data on a map. We have the neighborhood and all the different information, and we can really get quick insights into what's happening into this file and what is in there, and we get a high-level overview. And the pretty nice thing is that we can import the file by clicking on the import button. and we can decide about the mapping. So there is already a pre-calculated mapping based on what we have seen in the file. We can also change this. We can also change how the data is ingested using this ingest pipeline. And the full thing is stored here. And if you have the same CSV file again, you can reuse this configuration and upload this again, or upload this automatically using Logstash or Filebeat. So it's pretty cool to getting started with CSV files or getting started with other data sources to have a look into what is happening in the data. And now that we have the data in, we can look at the data in our maps. So there was a longitude and a latitude and some prices included. And I put this stuff on a map. I also used the GeoJSON file that comes with the download of this Airbnb data, and therefore I was also able to use the different in Airbnb. This is called neighborhoods. In German, it's called Bezirke in Berlin. And therefore I can now visualize the different neighborhoods here, and also visualize it in different colors based on, in this case, it's a price. But again, we would like to have a look into the data, so we can now zoom into this and at a specific zoom level. Now it is switching from the high-level overview into the concrete listings view. So this is freely configurable, but I decided to switch to the more detailed view when we go closer to the map. And now we can, for example, click on one specific element here, and we see, okay, this is host Victoria. We can see the room type, the price. You could also add the pictures here. And of course, we can also now drill down into the data. So this is the first time that we use a drill down. So I added a link to a dashboard behind this ID, and now I can switch to a dashboard to have a more detailed view on this specific ID here. So the dashboard is pre-filtered, and I get everything I need from the specific account here. I also included the maps on the dashboard to see where it is. So it is at the Leberstraße in Berlin, and I also get many more information. So how long you have to stay, the minimum, what's the price, how many listings this host have. I could also see the availability, but this is not loaded here. I only loaded 2 or 5 availability files because it's not necessary for our investigation today. And I also see the latest review per reviewer. So in this case, we have Luca and Clara, and really interesting, 2 bookings in I think 3 years. Yeah, so we have chosen the last 3 years. So this apartment has 2 bookings, and both of the 2 bookings were canceled by the host. So this is definitely one of the hosts I would not like to live in. What else we can see is we see that there is a sentiment loaded here. So I used ML to detect whether the comment here is positive, negative, or neutral, and to also see whether some postings are very positive or very negative. Also pretty easy to do, but pretty useful if you have a use case where you would like to collect Twitter feeds or collect Facebook feeds and comments and things like this, and you would like to know whether the overall sentiment about your company is positive or negative, then this is really cool to do. And I also use the top reviewer here to have a look into this. It's just a simple dashboard, but I wanted to show you how easy it is to jump from a map, or to go from a high-level map overview into one specific listing, having a detailed view into the listing, and also see the reviews and all the different things of the specific listing. and also that you get a little bit more familiar into the Airbnb data we have here. I hope Airbnb itself is known to everyone so that you know what is happening here. But I really want to show you how I work with the data and how I get information out of the data. Okay, so this is our so-called Airbnb dashboard now, and the next thing we can do, we can also use so we had a look into the reviews already, and the next thing we can do to check for risk indicators, which we want to do here, if we check for fraudsters, we can check whether there are reviewers that always using, for example, the same language. And to do this, we also have a special ML job. I need to open this one. And this is a categorization ML job. So we can use every free text and categorize this free text, whether there are common patterns in the text that that get reapplied in many different situations. So we usually use this for log categorization. So logs are pretty similar so it's easy to detect categories. It's a bit harder to detect those categories for comments because they usually are very different because they are made by users. But I wanted to check whether I can find something here. So I clicked into the anomaly detection here, and I was creating a job. And creating an anomaly detection job is really easy because it's an unsupervised learning. So the machine learning engine of Elastic really learns automatically what it needs to know if you use anomaly detection. And the first thing you need to do to create an anomaly detection job is to choose the data source, of course. And I will choose every review that has a comment. So this is my my saved search reviews with comments, and then I got a couple of things here to use. So I can check for specific metrics or multi-metrics. I can also check for population, which would be also a good thing. So I can check whether one of the or whether some of the reviewers behave differently than all the others. So let's say they have many reviews at the same time, or they review a lot of different houses or things like this. So which could be problematic in comparison to the rest. So a little bit like the outlier detection, but self-learning the features based on the history. And we can also use the categorization. I would like to show you how it looks like if we use the categorization. So we just click on this. We choose that we would like to see the full reviewer data. So this is from 2009 to 2020. I think it's enough to start with 2019. So we will switch to 2019, having 2 years of data. And we can see that there is our data in that we can use for this. The next thing we can choose is the categorization detector. So whether we would like to see anomalies in the count of in the event rate of a particular category, or whether we would like to find categories that occur rarely. I think this is more useful if you use it for log categorization. I would like to know whether there are categories used very often at the same time. So I will use this one, and I use the categorization field comments. And now it tells me, okay, I found enough data here, so everything is fine. Do you like to edit the categorization analyzer? I don't like to do this, but I maybe should do this because I have many different languages here. So for now, in the default, this is configured for English, so it works best for the English stuff. But I checked that it also works really nice for other languages, but it could be better if we use another categorization analyzer. We have a big topic in the documentation about this. Next step, we give it a job ID. We can add some additional settings like custom URLs where to jump to if we found some data, and also some advanced stuff that we don't need here. Then it validates my job, and now I can click on next to create the job. It took some time to do so. I have more than 500,000 reviews uploaded. That's why I did this prior to the meeting already, and we can now jump into the common categorization here and have a look. So I'm observing currently the 7th of August 2019, so there's still some things to do. It took some time because my ML node is pretty small here in my demo environment. But we already see some really nice results, so we can jump into the Anomaly Explorer and see what is happening. So we see there are a couple of suspicious ML categories. The numbers itself are created by Elastic, so they are not really helpful. But we can see also the anomalies across the different ML categories. And if we look down there, we can also have a look into the examples of every specific category. So for example, we see this specific category 798, and 798 is the host cancels this reservation. We have seen this already in our investigation on the specific host we have clicked on a second ago, and there are many anomalies of this specific category here. So we can filter, for example, for this category 798 by clicking on ML category equals 798, and now we can we get an overview only about this specific category, and we can check what happens here. So we see, for example, at the 1st of April or end of March, there was a lot of there were a lot of cancellations of reservations, and also here around July timeframe, July and June timeframe, there were also a lot of cancellations of the hosts, which is bad for the which is really bad for the Airbnb platform. So in this case, I would add every kind of these ML categories here. I would add as a risk indicator for this specific host, because this could be potentially a problem if this host is already always canceling the reservations prior to the stay of their of the people who want to stay within their apartment, and this could be a bad thing for Airbnb, and also results into bad reviews for this specific hosts. Yeah, let's switch back. I would like to use another ML category to have a look into the specific category, so we can see our top category here is a lot of things that going around about this thing is very nice. Obviously, also the thing is excellent. We have the description here. This was an unexpected non-zero value. Means typically no one is writing those things, and at this specific time frame, so at the 29th of June, this was here, someone was writing this much more than usual. So it's using this ML category much more than normal, and this is now resulted into one of the anomalies. We can also check here. So we see here someone is using many of the word great, and all the things around great. So he is using this 30 times. So we can check now for this specific review. We can view examples. So this is a pre-built thing. So we will jump into Discover and see examples of everything that belongs this category detector grade, and then we get a lot of things that fit into the category, especially everything that begins with grade. Could be problematic if it comes from the same user. If it not comes from the same user and not going to the same host, it's maybe not problematic, but what we need to check is that we should add this this indicator to our list of indicators, so that we can finally, and we will see this in a second, have a full overview about different indicators coming together and seeing the full picture then. So we detected already things that going in circles. We detected that people reviewing very much. So yeah, we need to check this again. And we also checked for different categories and for anomalies in the categories. So we checked already a couple of different risk indicators here. And the other thing I prepared is to go into our reviews dashboard again and checking who has reviewed in this specific time frame, also to get an idea about what has happening. So we see, for example, so I did reviews per host. So I see that Daniel was reviewing very often in this time frame. So he has reviewed 4 times for different hosts. So we can also see other users doing something like this. It's not crucial, it's not critical if it, but I think it's worth to call it a risk indicator if we have more than 3 different hosts per time frame, and we can easily detect those things with transform. So we can check for a specific time frame how many hosts one reviewer has been reviewed, and if there is more than 3 at the same time, it could be that this is problematic, especially if he is if this reviewer is doing this very often. Another thing I've checked is here for the is the real details of the comments. So we can also read, for example, if we filter down to Daniel and want to check more about Daniel, we can really see what he has commented, and we see that he is commenting everything at the same time. So it's the same day. For different hosts, but he is using different languages, but it could be a problematic case here. It could also be that he has taken the time at the 29th of April to review everything he has lived in. For me, it looks a little bit suspicious. And if we now would see that there are multiple reviewers doing this at the same time for the same host, we can expect that there's something suspicious going on. And this is something we do in Graph again. So I will jump back into the graph analysis here. That is now also checking for the reviews. So I just created one for the reviews in Berlin. And what I wanted to see is whether there are hosts and reviewers shared by someone. So I already prepared this. So for example, we have this cluster here, where we have 1, 2, 3, 6, 10 different, so this is the reviewer, 10 different reviewers reviewing many different hosts, but these 10 reviewers have all these hosts in common. So every of these reviewers is reviewing these different hosts, and so it looks like, and we can also double check this, that these reviewers are getting paid for reviewing those things. So this is definitely something. So if one reviewer is reviewing many of these, it's okay. But many reviewers reviewing many different, reviewing always the same host, looks like the hosts have paid to these reviewers to review their stuff. And now we could also check for the for similar wording and things like this, for having the same ML categories. And then we could go deeper into the analysis for the specific accounts. And again, this is pretty easy. I just used my reviews index, which contains of host, listing, and reviewer. And then I was searching for everything, and I will see this this pattern here. And I also have seen this pattern of Barbara. So we see, so this is how it usually looks like. So we have many different users, only and reviewing one or two hosts. So it's not very common that one reviewer is always reviewing the same thing. And it's also a bit suspicious if we have it like this, that three reviewers always reviewing the same host. So we have a little bit the same pattern like we had before. So we can now get all the linked stuff. So these are all the hosts this three have in common. So it's also a bit suspicious that that many, so that we have three different reviewers reviewing all the same thing. So I think it's really uncommon that three different people stay in the same houses and for many different reviewers and for many different hosts. And Barbara seems to stay very often at Airbnb. So if we check for the linked stuff, so I think this is not a problem. So it could be that she is sleeping very often with Airbnb, but it looks a little different than the usual pattern. And again, we can also check here. So I can also do things like this, reloading the data, checking what comes out of this. So it reloads now everything. We can also, for example, click into one specific reviewer and expand this reviewer if we would like to learn more about him. And so this reviewer is reviewing many different hosts, but he has not many hosts that he's reviewing the same thing. So this is how it usually looks like if you, so we have, for example, Barbara, he's doing a lot of different things, and we have this one who's behaving normal, I think. So he only has one thing in common with Barbara, which is fine because Barbara is using many different hosts. And so this way we can really graphically see what is going on in the data, and jumping from reviewer to host, from reviewer to host, and see what is happening and how the EgoNet is looking like. Okay, so now I talked a lot about the different risk indicators and how to detect them. Now I would like to show you how to bring everything together. And the way we do this is that we create so-called alerts index. The alerts index is getting filled up by all the different things we have done so far. So we can use this for to store our transform results into, to store our outlier results into. We can use it to store our graphical results into. There's one thing, if you would like to detect those patterns, where they are, if you like to detect those problematic patterns like this programmatically, then you need to use a tool like Python in the background, which is accessing the Graph API. So the Graph API can be found here in the inspect bar, and then you can use this request to do the same thing in Python, and then you can count, for example, how many reviewers have the same host in common. And if you see something like this, so greater than 4 or greater than 5, then you can add a risk indicator and add this to this alert index. No, this is the result. So this to this alert index, and this is what we have done here. So we collected a couple of different risk flags. So let's have a look into the risk flags. So we see that there are risk flags about self-reviewing networks. So it looks like someone is reviewing their own things. That we have a risk type where someone is doing so multiple users are doing the same thing at the same time, using the same language. We have seen how to do this. We have a high sharing of assets, so many different risk indicators that we added here. We also checked for pictures in the different listings, whether 2 or more listings are using the same pictures, and adding a risk indicator for that. So we really putting all the risk indicators into this risk indicator index, which is called Airbnb alerts. And then we use this Airbnb alerts again to visualize a graph. So we visualize now the Airbnb alerts. There is the host included, the listing, the reviewer, the risk flag itself, and whether this is a hash problem. And we see there are a couple of smaller things here. They are only having 1 or 2 risk indicators. This is probably not a big problem. So for Airbnb and also for other things, so it could be that there is a risk indicator, but it's not really a risk or a fraudster. But there are others like this big net here or this big net here, where things look more problematic because we have a collection of risk indicators in one single cluster. And if we now have a look at this big ego net here, we see many different things happening with this specific hosts here. So we see that there is, so if we click on the different hosts, we see that this host is always sharing the name Sam, for example. So really, and this host Sam is using is posting listings that are sharing the same photos. So really suspicious that he is creating many different listings that sharing the same photos. It could be, so we can have a look into this, open dashboard, listing photos. So we can have a look into Airbnb itself, and then we will see this specific room, and he probably have some pictures of London here, and he is reusing this, so which would be fine. So let's have a look. So this is a nice flat. And then he is using something like this in every of his listings. But he is also doing the same thing, but with more than 2 pictures here on the on this thing. Now we can also have a look into this specific listing, and he is reusing the same pictures for. You can see it again. He is also reusing this pictures for another apartment. So really another thing where we believe that this is a real fraudster. And what else he is doing? We see that there are a couple of risk indicators here in the middle. This risk indicator say, okay, shared associations with people with a confidence of 2.17 per host. So this means, okay, there is a reviewer that is sharing the same things, or reviewing the same things, the same assets for all the different hosts here. So he has a lot of associations, so a lot of connections in common with other users, so with them, for example. And this results into this risk indicators, and the risk indicators are really useful because they bring those things together and make it real visible for us in this specific cluster here, so that we can see what this specific user is doing. For example, again here we see that this user is using the same pictures across multiple different listings, and we can see that that all the different hosts get reviews for their specific listings from the same reviewers, which is also suspicious. And not only this, these reviewers are also using the same language, so they are resulted into the same categories of our ML categorization, and this is again real a bad indicator for fraudster in this special use case. Okay, now it's 7 p.m. So my time is over, and I hope I was able to teach you a little bit of how to use Kibana and how to drill down into the different things, how to create drill downs, how to jump from one visualization and from one observation into the other. If you have any questions, feel free to ask now in the chat. I will stay for another few minutes to answer all your questions. Yeah, otherwise, I will say thank you in a minute. And you can also ping me in the chat if you like the session. Also, if not, of course, so any feedback is welcome. It's always hard to prepare sessions like this and then don't get any feedback from the attendees. So it would be really nice if you can share your feedback in the chat also.
Thanks, Felix. We're also going to send survey after that. So I'll let you know also the feedback, what they say. I will also send the recording and the slides afterwards to all the attendees. But yeah, please let us know if you have any questions.
Yeah, well, these slides are fully canvas, so we can't really share the slides.
No? Okay.
I can export a PDF of it.
Yeah. Whatever you can share with me, I'll share it with the attendees. Okay, well, if no one has any questions, then we'll wrap it up.
Okay, so thank you very much to join also at this late hour, and hope to see you soon in another session, the private talk or via LinkedIn. So always happy to discuss many different things. Bye.
Bye, everyone. Have a good evening. Hope to see you soon again.